Hello everyone, I'm Dr. V. Bharati, Assistant Professor in Botany, Department of Zoology, Fatima College, Madurai. In this video, I'm going to give a short lecture on structure and properties of triglycerides. We already know that lipids are classified into simple lipids, compound lipids and derived lipids. Triacylglycerols or triglycerides are the simple lipids. These are the esters of glycerol with fatty acids representing the most abundant lipid in nature. They serve as primary fuel reserves in animals and constitute 98% of total dietary lipids. The major components of storage are depot fats in plant and animal cells but are not normally found in the membranes. Glycolipids and phospholipids are seen in the membranes. They constitute about 98% of the total dietary lipids and the remaining 2% consists of phospholipids and cholesterol and its esters. They are insoluble in water and non-polar in character and commonly known as neutral fats. The picture is representing the structure of an adipocyte and we can see that the triacylglycerols constitute the major part of the cell. Fats primarily occur in adipose tissue. Adipocytes of adipose tissue predominantly found in the subcutaneous layer and in the abdominal cavity. They are specialized for storage of triacylglycerols in the form of fat droplets which fill almost the entire cell volume. So most fats and oils upon hydrolysis yield several fatty acids as well as glycerol. However, the milk of spiny anteater is an exception in that it comprises almost pure triolein. Triacylglycerols is stored in a relatively water-free state in the tissue in comparison to carbohydrate which is heavily hydrated. Chemically, triglycerides are esters of glycerol with 3 fatty acid molecules. Structure and function. So the chemical nature of glycerols are the esters of fatty acid with 3 fatty acid molecules, non-polar and hydrophobic in nature. About the energy reserved, they yield 9 calories per gram, over twice the energy of carbohydrates, 4 calories per gram. That is about the carbohydrates energy yield, which is stored in a water-free state. There are also isomers of triglycerides. When the groups attached to the carbon 1 and 3 differ, a center of asymmetry is created at C2. So, the two optical isomers may thus be represented as shown in the naturally occurring fats or of L type. Simple triglycerols contain the same type of fatty acid residue or all the 3 carbons in all 3 positions. Example, tristerin, tristerolyl glycerol. Okay. Here they are named after the fatty acids they contain. Examples are tripalmitin, tristerin, triolein. The OH groups on the glycerol molecule are esterified with the same fatty acid, stearic acid, palmitic acid, oleic acid. Thus resulting ester is called a simple triglyceride or it may be also represented as a symmetrical triglycerides. Here are the structure of tristerin, triolein and tripalmitin. Whereas the other type of triglycerols are mixed triglycerols. By the name we can understand that they are made up of triglycerides of nature which are mixed triglycerides. They contain 2 or 3 different fatty acids units in the molecule. So these representatives of such mixed triglycerides are oleodipalmitin, oleopalmitostearin. So you can see that will contain olein and 2 palmitin and it may also contain 1 olein, palmitin and stearin. So they contain 2 or 3 different types of fatty acid residues. Fatty acid attached to C1 is always saturated and which one is attached to C2 is unsaturated, while that on C3 can be either saturated or unsaturated. So what is the difference between simple versus mixed triglycerols? As we've already told, they are containing the same type of fatty acid residue at all the 3 carbons, that is alpha, beta and alpha dash. Whereas the mixed triglycerides, they contain more common in nature, which is containing 2 or 3 different fatty acid units. They are also called as simple triglycerides. They are also called as symmetrical triglycerides, whereas mixed triglycerides, they are called as asymmetrical triglycerides. Now coming to the fats which are present in animal and plant. What is the difference between the fats which are present in animal and plant? So animal fats, they are rich in saturated fatty acids, palmitic, stearic acids, with high melting points conferring to solid state. Exceptions, chicken fat, fish fat, they contain more unsaturated fatty acids. Whereas the plant fats, they contain the proportion of unsaturated fatty acids, especially polyunsaturated fatty acids with low melting points conferring the liquid state, their liquid state. Higher content of unsaturated fatty acids compared to animal fats they have. Now coming to the physical properties, they are non-polar, hydrophobic, insoluble in water and soluble in organic solvents. Specific gravity is less than water, therefore fats and oil float on water. They serve as solvent for other fats. Example, fat-soluble vitamins A, D, E and K. The saturated fatty acids have higher melting points than unsaturated fatty acids of corresponding length. What are the chemical properties? Hydrolysis. Okay. Triglycerides can be hydrolyzed to produce glycerol and fatty acids in the presence of acid and heat or with a suitable lipase enzyme under biological conditions. Hydrogenation is an industrial process of adding hydrogen atoms to unsaturated fat until they become saturated. Hydrogenation of fat is a process used in industries. It is a very common process to produce products like vanaspati. Okay, industries, food manufacturers to synthesize modified plant fats called hydrogenated fats that share similar texture and taste characteristic with saturated animal fats. Saponification, this is also a process which is important in soap making, this property. The process of hydrolysis of fat by aqueous alkali, either it is sodium hydroxide or potassium hydroxide, to yield glycerol and the salt of fatty acid is called saponification or alkaline hydrolysis of esters. Soaps are sodium or potassium salts of long chain fatty acids. Soaps are usually their high economic importance in the industries. Halogenation. Unsaturated fatty acids have the ability to bind halogens like chlorine, bromine and iodine to their double bonds. It is a very important property which determines the degree of unsaturation of the fat or oil that determines its biological value. Rancidity. Rancidity usually is a term used to denote unpleasant odors and flavors in foods resulting from the deterioration in the fat or oil portion of a food. Sometimes you may experience some foul smell if you buy any oil products from the shops when it is being stored for a long time. This is because of the decaying of the fat, that is called as rancidity. The triacylglycerols in fats with low molecular mass carboxylic acid undergo oxidation, the technical term oxidation, very quickly when exposed to air, moisture and light or hydrolyzed in the presence of bacterial lipases. The other property of the triacylglycerols are their antioxidants. The substances which prevent the occurrence of oxidative rancidity are known as antioxidants. Trace amounts of antioxidants such as tocopherols, hydroquinone, gallic acid and D-naphthol are added to the commercial preparation of fats and oils to prevent rancidity. Propyl gallate, butylated hydroxynulose and butylated hydroxytoluene are the antioxidants used in the food preservation. Lipid peroxidation. In the living cells, lipids undergo oxidation to produce peroxides and free radicals which can damage the tissue. The free radicals are believed to cause inflammatory diseases, aging, cancer, atherosclerosis, etc. It is fortunate that the cells possess antioxidants such as vitamin E, urate and superoxide dismutase to prevent in vivo lipid peroxidation. Quantitative analysis. Acid number, which is the milligrams of potassium hydroxide to neutralize 1 gram fat, indicates free fatty and acid quantity. Iodine number, grams of iodine absorbed by 100 gram of fat, measures degree of unsaturation. Richet-Hessel number, millimeters of 0.1 normality KOH to neutralize soluble volatile fatty acid from 5 gram fat. Saponification number, milligrams of potassium hydroxide to saponify 1 gram fat indicates average fatty acid chain length. Polanski number, it is the millimeters of 0.1 and KOH to neutralize water insoluble volatile fatty acids. Acetyl number, milligrams of KOH to neutralize acetic acid from acetylated fat, measures free hydroxyl groups. What are the points that should be taken when we learn this lesson? They are the primary energy storage, structural distinction, it is not found in membranes, they save us only as the storage fat. What is the difference between the animal fat and the plant fat, and what is the physical and the chemical characterization? Thank you.